Hello everyone. In this video we are going to introduce the center of mass. Okay, let's start with one. Let's start with one. This PowerPoint first. Okay. First of all, why we need center of mass? Because sometimes in our physical system, sometimes we have to analyze a system of particles or system of many particles. Yeah, just like the Powerball, you see the screen. But sorry, not screen. You see the PowerPoint. Yeah, there's a Powerball. Okay, there's a Powerball. Okay, there's a wind blows over in this round container, and lots of balls circling in this place, and lots of motion. And each ball is doing their own motion. Okay, if you try to analyze the motion of every particle in the system, that will be very complicated. Okay, because each particle is valid Newton's law of motion. So that means each particle has their own equation of motion. So you have to, if you want to try to understand the trajectory of each particle, you have to calculate the equation of motion of each particle, and there will be very complicated problems. Okay, but in fact, it's difficult for human. It's difficult to human, but it's not difficult to computers. Okay, but that's back to the human situation. Okay, for such a complicated system, can we reduce the complexity of the problems? Yes, we can. We can do the reduce the complexity of this problem. So we need a concept called center of mass, and center of mass is a very special point. Okay, center of mass is a very special point. Okay, and you can this point you can treat it as all the total mass of the system of particle. The mass is concentrated at that particular point. Yeah, the total mass of the system of particles is concentrated at that particular point. Okay, and the external force the overall external force is acting on that particular point. Okay, so it just the center of mass just treat a lot of particle, treat a system of particle as a one point, and you only have to consider that particular point, and that particular point, it has the mass equal to the total mass of the system of particles, and the net force is acting. You can treat the whole system. Yeah, it looks like the whole external force or all net force is acting on that particular point, and this can be proved by mathematics, and I will show you. So the center of mass is a very special point. Okay, and center of mass, you cannot see it. Okay, it's difficult to see it. Yeah, if you can see the center of mass, you have a very special talent. Yeah, center of mass, in most of time, center of mass is difficult to see it. Okay, so you need to do the calculation to know its position. Okay, that's why we need to learn how to calculate the position of center of mass. Okay, and center of mass can reduce the complexity of the system of particles. Okay, we just treat the whole particle as just one point. Okay, at this point, the mass is equal to the total mass of the system, and the net force is acting on the center of mass. Okay, and the next slide. Yeah, that's one I want to say. It's the center of mass can reduce the complexity of the system. Okay, for example, this is a man is doing the walking. Okay, and actually the man can be viewed as system of particles because the man is composed of different parts. Okay, for example, you have a head. Okay, and you have a body, you have a hand, you have a leg. Okay, and this all together become a man. Okay, so if you want to describe the motion of a man, actually you have to describe the motion of a head, motion of your body, motion of your head, motion of your hand, and motion of your legs. Okay, actually you have to do the motion of each part. Okay, but that is like what I said. Okay, if you want to analyze the motion of each part, the problem will be very complicated. Okay, but if we can find the center of mass of the human body, okay, we can, okay, the trajectory of this center of mass of the human body, okay, will make the problem easier. So when we describe the motion of the man, the walking man, we just describe the motion, the center of mass of this man. Okay, that's what this picture trying to show. The motion of this man can be treated as the motion of the center of mass of this man. Okay, and analyze the trajectory of the center of mass is much easier than describing the motion of each part of human. Okay, it's much easier. And there's a tensor, and this the right hand side is a tensor. The motion of tensor is complex because multiple forces act on each part of his body, right? But if you just look at, okay, this is a very special picture. This white line is the center of mass of this tensor. Okay, and this is drawing the trajectory of the center of mass of this tensor. Okay, it looks like it's just a projectile motion, right? Projectile motion. Yeah, actually, it really is. It's a projectile motion. The center of mass is doing the projectile motion. And projectile motion, we introduced projectile motion before. Analyze the projectile motion. It's not that difficult, right? Okay, if you just you can treat the complex motion of the tensor just as the center of mass of this tensor doing the projectile motion. This will make the analyze of the tensor, the motion of the tensor become easier. Okay, you don't have to analyze the different part on this tensor. You only have to focus on the center of mass of this tensor. Okay, let's make problem easier. And the next one is, that's an important concept because center of mass, you might think center of mass is in the body. Okay, but like often that's not true. Okay, sometimes that's happen a lot. The center of mass is not guaranteed in your body. Okay, for this example, this man, he's doing a different posture, a different gesture, or different gesture, and if the person doing different gesture, 姿势, I'm not sure 姿势中文怎么讲啊？姿势啊 ，Let me check 姿势中文怎么讲 ？Posture, yeah, posture. Okay, posture. Yeah, posture. Okay. The man is doing different posture. Okay, so the man doing different posture, and you will see the center of mass just vary differently. Okay, if this man doing a posture like this, the center of mass is not in his body. Okay, the center of mass is around. Is leaving his body. It's not right in his body. Okay, let's just tell center of mass is not guaranteed 100% in the body. Okay, and so and the next slide is I think I put some video on the Moodle, so I won't demonstrate. I won't talk about this slide too much. It's just show, like I said, because for human, it's difficult to analyze the trajectory of system of particles. That's why we need center of mass. But that's difficult only to human. But for computers, because they have very high computational power, so actually analyze or calculate the trajectory of each particle in a system of particle, it's not that difficult to computers. Okay, and so there's a simulation technique called molecular dynamics. Okay, it's just like the basic idea, just calculate trajectory of each particle in your system, and you can do 1,000, 10,000, 1,000 atom trajectory. Okay, but yeah, just tell you there's the simulation technique called molecular dynamics. And the final one is, so we have to choose to demonstrate how to calculate center of mass, because like I said, center of mass, you cannot see it. So you need to calculate its position. And so, and we will show two different systems, how to calculate the center of mass in two different systems. One is a discrete system, the other is a continuous system. And we'll start discrete system first. So in the discrete system, discrete system, like as in for our exam for this center of mass calculation, the coordinate of each particle is a certain value in a specific range. Okay, that's discrete system. The coordinate is a certain value. Okay, but for the continuous system, your coordinate could be any value in a specific range. Okay, and actually there is a connection between the discrete system and continuous system. Okay, eventually you understand. Okay, there's a connection between discrete and continuous, because they are very similar to each other. Okay, and let's start. I just start with some concept first. Okay, in the next video I will do some calculation on discrete system. Okay, so the concept is, suppose let me change this. Okay, suppose we have system of particles, and the R alpha is the position vector of each particle. This R alpha is a position vector, position vector of each particle, alpha, and what the M alpha is the mass of each particle alpha. Not each. Okay, that's okay. Maybe each is not proper use. Okay, the position vector of particle alpha. Okay, particle alpha. Okay, the M alpha is the mass of the particle alpha. Okay, and alpha is just a label. Alpha can be 1, 2, 3, 4, 5, to n. Okay, suppose we have an n particle system. Okay, n particle system. So alpha is just a label. Particle 1, particle 2, particle 3, blah 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 blah, and keep continuing to n. And okay, so how to calculate the center of mass of this system of particles in discrete system? Okay, because center of mass, okay, it's a vector. The center of mass. If you have a coordinate system, your center of mass also is a position vector. Okay, the position vector can identify the position of center of mass. Okay, so the position vector is okay. So the center of mass is also a vector. Okay, you have to use the position vector to describe the position of center of mass. And suppose we have a 3D system, so it has x component, y component, and z component. And the x component, x coordinate, the coordinate of x component is called xcom, and the coordinate of y component is called ycom. The coordinate of the z direction is called zcom. So how to calculate the xcom, ycom, and zcom? And actually, it's the concept is very simple. So you just okay, let's see. You just summation alpha. Okay, summation OM alpha. So it's the mass of each particle and times its own x coordinate, and then times its coordinate and summation all of the particle in the system and divided by summation alpha M alpha. Okay, so the summation alpha M alpha is just the and we say the center of the total mass of system. The total mass of the system is the capital M. Okay, so this formula will become like this. Capital M is total mass. Total mass of the system. Total mass of the system. Capital M, total mass of the system. And the denominator numerator or numerator, denominator, numerator. Which one is 分子 numerator? Let me check. Numerator or denominator? Numerator. Maybe numerator. 分子. Okay, numerator. Okay, maybe I say something wrong in another video. Okay, the numerator is unchanged. Summation alpha m alpha x alpha, and the summation alpha here we just because there's much not space here, so summation alpha actually is the summation alpha equal to e to n. Okay, and this is more, and because I don't have much space here, so I just use abbreviation summation alpha. Okay, actually it's summation 1 over n. Okay, so the formula is just very simple. So the each mass in your n particle system, the particle of each mass times its own x coordinate, and summation altogether divided by total mass is equal to the x coordinate of center of mass. Okay, so similarly, so if YCOM is m alpha times y alpha, that's each the mass of each particle times its own y coordinate, and summation all of them divided by capital M. And sorry, this is a ZCOM. Okay, ZCOM. You summation you summation each particle mass times its own z coordinate divided by capital M, and summation altogether capital M, you get the z coordinate of center of mass. Okay, so calculation of center of mass in discrete system, it's not that really difficult. And so, and the next we'll use the example in the textbook to demonstrate how to calculate the center of mass on discrete system. Okay, this video is very brief introduction of center of mass. Okay, and see you next video. Next video we have some demonstration of calculation. Okay, see you in the next video. Bye bye.